equations extension. This is going through quickly how to appropriately solve equations. Remember, we are given an unknown number, x. Something was done to it and we're told the result. We had x, 3 was added, and we got -2. Your process for solving the equations is to reverse, in reverse order, what was done to the pronumeral to get it on its own and find out what the result is. So one-step equations only have one numeral on the side with the x. These are all one-step equations, and so they're only going to take one alteration to fix. We work out what was done to the unknown number. In this case, 3 was added, and we do the opposite of that to both sides. That will cancel this out here. So the opposite of +3 is -3. +3 minus 3 is 0. It cancels out, and we're left with x equals, and we write what we're going to do. I had -2, and I subtracted 3, and that is I have subtracted 3 from both sides. The 3 is gone from there, and I'm subtracting 3 here, so x equals -5. We check by substituting back in. -5 plus 3 is -2. We're correct. So this is appropriate working for a one-step equation. Here, y minus 8 is 0. I have y, and 8 was subtracted, and I got 0. So I do the opposite of taking away 8 to both sides. I add 8 to both sides. That leaves me with y on its own, and y will be 0 plus 8. Y is 8. Substitute it back in to check. 8 minus 8 is 0. We're correct. Here I've got 2z equals -3. That is, I had z and multiplied it by 2 and got -3. I divide by 2 on both sides to get rid of this times by 2. Times 2 divided by 2 cancels out, and I'm left with just z here. -3 divided by 2, and I'm actually okay to leave this as the answer, or I could work it out as -1.5. So we're getting away from the working that you might have learned, where they said, what did we do to x? It was +3. I'm going to -3 on both sides. This is not mathematically correct. It's not a good thing to do. So we're working instead on showing the exact sum that we're doing to find out what x is. If you're not sure on any of those, go and practice some one steps, then work out the two steps. Two-step equations are called that because they've got two numbers hanging out on the side with the pronumeral. Now we have to get rid of them both, but it's like unwrapping a present that's got several layers. I had the present, I put on the first layer, I put on the second layer. I've got to take off the second layer before I take off the first layer. So we do the opposite of the order. In fact, we do reverse order of operations, reverse BODMAS. So what happened over here? I had x. Order of operations says it was multiplied by 2 and then 3 was added, and I got 11. So I'm going to have to deal with adding and subtracting first because I'm reversing what was done. So I'm going to subtract 3 from both sides. 2x equals 11 minus 3, so 2x equals 8. Now I've got a one-step equation. That's easy. What was done to x? It was multiplied by 2 and I got 8. I will divide by 2 on both sides. X equals 8 divided by 2, x equals 4. Substitute it back in to check. 2 times 4 is 8, 8 plus 3 is 11. We're correct. So you're using reverse order of operations. I have y, it was divided by 2 and then 6 was subtracted and I got -1. So we reverse what was done to it. First I've got to add 6 to both sides. Y divided by 2 equals, I've got -1 plus 6. Y divided by 2 equals 5. Negative 1 plus 6. Now I've got a one step. I had y, it was divided by 2 and I got 5. So y will be 5 times 2, y equals 10. Now you can start showing a little less working as your equations get more and more complicated. Sorry, I'll just separate this off there. I ran out of space. You could probably get away without showing this line and without showing that line. Same here, you could probably get away without showing that line and without showing that. You can't get away with it on one step because that's the only working there is. So you're quite welcome to show all this working. It just gets a little tedious. So on these two, I'll show you the reduced working that's acceptable. Now remember, there's invisible brackets around a sum on top or bottom of a fraction. So this was done first. Z plus 4, Z had 4 added, and then the result was divided by 3. So we've got to times both sides by 3. Z plus 4 is what's left. 8 times 3 is 24. So see how I skipped that line, but it's quite clear what I did. Now I've got a one step, I've got Z and 4 was added and I got 24. I've got to take 4 away from both sides, Z equals 20. So it's acceptable to show that much working for a two-step. 2a divided by 8 equals 1. So remember, we're reading this way, so it would have been a times 2, then divided by 8, so we times by 8 first. 2a equals 1 times 8 is 8. This is now a one step. A times 2 is 8, so I divide by 2 on both sides. A equals 4. So that's your two-step. Probably go and practice at that stage. Practice your two-step equations. Equations with brackets, you've got two ways of dealing with this. 3 outside of x plus 2 equals 18. You can expand and you'll get a two-step equation and solve it. Or you can say, well, this was x plus 2 and it was multiplied by 3 and we got 18. So I'll divide by 3 on both sides and I'll be left with x plus 2 equals 18 divided by 3 is 6, and now I've got a one step. It has plus 2, subtract 2 from both sides, x equals 4. If, though, there's more than just the brackets, then expand your brackets first. And it would always work to expand the brackets first. 3x plus 6 equals 18. Subtract the 6. So I just expanded there. Nothing changed in the equation, I just expanded. Subtract 6, 3x equals 12. Divide by 3, x equals 4. Same result, pretty much the same amount of working. It will always work if you expand your brackets before you go getting carried away with solving. If there'd been anything else involved, if I'd had a question like 3x outside of x plus 2 minus 2 equals 16, you probably wanted to expand that first, but either way will work. If you have equations with pronumerals on both sides, then you must get all the pronumerals to one side first. And you do it by moving the pronumeral with the smallest coefficient. (3x) or 7x, we're going to move the 3x. How do I get rid of 3x? I take away 3x from both sides. I'll be left with 2 over here. 7x minus 3x is 4x minus 18. Then I've got 4x minus 18 equals 2. If you wanted at this point, you could change the sides. So 4x minus 18 equals 2. I haven't done anything. I've just got the x on the left where I want it. Then it's a two-step equation. add 18 to both sides, 4x equals 20, divide by 4 on both sides, x equals 5. So that's been an overview of a whole bunch of different types of equations, but they're actually all based on one-step equations. Because a two-step, you do one step, and you get to a one-step. This one, you get to a one-step equation. So if you can do your one-step equations right, and remember the reverse order of operations, then you can do it all.